Hey guys, welcome back. I hope you are doing well. So this is my third time I am solving question without actually I don't know what's the question is, and I thought let's create a video that it might help you that how to approach the question. Since I haven't seen yet that what the question is, so without any further, let's get started. We are going to solve two questions. One is the LeetCode today's problem, and the other is GFG today's problem. Okay, so without any further, let's get started. So this is my screen. Okay, and let's try with the LeetCode. Okay, 1 hour will be fine. Let's see. Find the prefix common array of two arrays. What does this mean? A prefix common array of A and B is an array C such that C of I is equal to the count of numbers that are present at before and the index I in the both A and B. Return the prefix common array of AB. The sequence of n integers is called a permutation if it contains all integers from 1 to n exactly once. So I just read this question and at this point, it just, I didn't understand anything. But let's see with the example. So we have the array A and the B, and our answer look like I is equal to 0. Why? The number is common. So C is equal to 0 is 0. Okay. The ith number which is common in the both is 0. That is why it's 0. Okay. At I 1, the 1 and 3 are common in A and B. So uh, the C of 1 is 2. What does this mean? Let's see the other. I is equal to 2. We have 1, 2, 3. 1, 2, 3 means I is equal to 1, 2, 3 common in the A and B. So the answer is 3. And the I is equal to 3. So we have 1, 2, 3, 4 common in the both. So the answer is 4. Okay. At every index, if you see, prefix common array A and B is C, A and B is an array C such that the C of I is equal to the count of numbers that are present at the before or after the index I in the both A and B. So at the I is equal to 0 means the 0th index, no comma in the both before and after, because if you see at the 0th index, there is before there is no element and after there is 3. So probably I missed something. Okay. At I is equal to 0, no number is common. So that is why it's 0. And for the 1 and 3 are common. How? Let's try to draw this array 1, 3, 2, 4. Okay, this is our A and this is our B. C 3, 1, 2, 4. 3, 1, 2, 4. Okay, and our answer is 0, 2, 3, 4. 2, 3, 4. Okay, so this is our answer, right? And at this point, my suggestion is for all the beginners that do not try to code it. just understand the problem itself first. Okay, if you got the problem, what's the meaning, then you can think about the solution. Okay, but first need to know the problem itself, right? So at the I is equal to 0, there is no common. What does this mean? And if you see, it's clearly indicating that prefix common array. Uh, Probably it's about the prefix. Okay, whatever elements we have with the common in the both array before and after for this particular index. Okay, the C of I is equal to the count of numbers that are present before and after index I in the both array. Okay, for 0, before there is -1, so no one. After, let's see. So after 0, we have these things for the both arrays, right? So how many of them are common? Probably 2, right? Uh, if I'm targeting to this index, okay, so let me think this. So I'm targeting to this index, and these are the after part, okay, and you can see these matches this matches this. So we have two elements, but the answer is 0. Probably it's stating that uh, the before stuff. Okay, let's see. For I is equal to 1, we have 1 and 3 common in the A and B. So that is why its answer is 2. For you can see the answer C, I is equal to 1, the answer is 2. So before and after this index. So before we have 3 and 1 common in the both arrays, right? That is why probably the answer is 2. And if it's 3 at the index 3, meaning this before and after, uh, let's say only before, since it's stating to the prefix something. Okay, so how many elements are before? Okay, so these many elements, and are these common? How many common with the both these three, right? That is what the answer is 3, I guess. Similar for this one, but since it's not clear for me, I'll take the another example to understand it better. So 2, 3, 1, 3, 1, 2. Let's say 2, 3, 1 and 3, 1, 2. So the answer is 0, 1, 3. 0, 1, 3. Okay. Let's see. The one thing I'm figuring out that the answers 0th index is kind of look like always 0. But let's see. For the index 1, how many elements before and after common in the both? Okay. So there are one element before and after for this index, right? One is looking common to me. Okay. Because before this particular index, we have 3, right? And it's matching with this one. If there is one this uh, point, then we can probably say these are 3 things. And let's see for this one, 3, 1. So yeah, we have this whole thing here. that is what I'm thinking. Okay, let's see another example. Is there any? No. I it's guaranteed that A and B are both permutation of integer n, meaning there is n. All the elements are between 1 to n, and at max n will be 50. So so how can I solve this problem? Sequence of n permutations. For index 1, 1 and 3 are common in both. For index 2, uh, okay, uh, I've mistaken by saying before and after. So it's only this one, at or before. That is what it means, prefix. I'm really sorry. I just uh, incorrectly read the question. So no worries. The thing is, it's meaning if you are index I, then you can include that I and before part. And let's see how many common in the both arrays, and that will be our answer. That is the question. So it's pretty simple. Uh, to understand the question, I'm really sorry I took this, 10 minutes to figure out what the question says. Okay, probably because I started the video. That is why I just my head is not uh, processing the text properly, processing the question properly. Okay. So yeah, the question, now we understand the question first. Understand the question for sure. Okay, understood the question for sure. Now we know what we need. At every index, we just need to check how many elements are the common, the before or at the index, okay, in the both arrays. That's the simple question. Now, how we can figure out at every index, let's say index I, how many elements are common in the both arrays. So we need some sort of technique that will check how many common in the both. Okay. If we start from the beginning, so we probably have the answer, uh, the index 0, meaning that how many elements are the common in the both before or at the index. So if we go at the index I, this is our answer plus the current index status. Meaning, let's take the example what we 1 2 1 3 2 4. Okay, 1 3 2 4, and then B 3 1 2 4, 3 1 2 4. Okay, so and our answer will be like, at, let's say this is 0th index, second, first, second, third, right? For this index, is there any match? No. Uh, so we can put it 0. Okay. Now go on. If there any match for this index, you can see for this one and starting from this one. Okay. This match, right? So we can include in our answer. Let's go on the next. Okay. And you can you don't, we just need to check how many match in this window. That is what I'm saying. Okay, so you can see there are 2 matches, so the answer will be 2. Okay, now we slide expand the window. Okay, So let's say this one, how many matches? 1 plus 1, which is, sort of coming from this 1 plus 1 and extra 1. That's for the current window, current index. Now we expand, and then our answer will be 3 coming from this and plus 1, the current match. Okay, that's the core ID that I'm able to think of. Okay, so we need to figure out, since it's a permutation, okay, so we have to think in that direction also, but not right now, since we should come up with the brute force approach at least. Okay, and the approach is simple. For the brute force, okay, which will be like, for every I, okay, for every I which is 0 to n, will traversing. For example, we are at the index 1, so we have to check how many elements are common in this window. Okay, uh, in this window. Okay, so uh, you know, let's take a window. We need a sort of a data structure which will put these elements to tell us that uh, these are the valid ones, and you can take the window size itself. Okay, not window size, but what I am thinking is we need some sort of data structure. uh, we'll put the both arrays elements into it, and it will give us that how many are common. Okay, let's say this is get common elements. Okay, that's the working of this. So at this point we know this will the work of this, but we actually did not implement it, right? We will implement later, but just assume that this will give us how many are common at this point in the both arrays. Okay, so get common, I will put the I, obviously the both arrays also, and it will give us the count, and we'll put the C of I will be that count. Now the most interesting part is how we can get that uh, algorithm, which will give us how many uh, you know are common in the both. So let's think in that direction now. So it's a pretty simple if I directly started the code, but right now I'm also explaining. So if I started code, even there is nothing up in my mind. I don't know how I just code that algorithm. But since I'm trying to explain, so I actually need to think about it, like how I'm gonna uh, code it. So there will be like, let's check. There are, since it's mentioned there are n numbers, right? The 50 at most. So we can put an array of 50. Okay, and we'll put the numbers. Okay, so 1 from the array 1 and 3 from the array 2. At this point, okay, every time we create this window, okay, and not every time, but we can optimize later. But let's say for this instance, let's we create every time and put the all these elements into it by the frequency stuff. Okay, so at the first index, meaning the first number, increase the frequency, and later we can traverse this frequency array, and whoever's frequency greater than 1, it's at max 2 windows. Okay, but whenever we found greater than 1, we count plus plus, meaning that this element present in the both. Okay, but for that we have to make sure uh, there is no duplicacy in the arrays, right? So it's mentioned that it's a permutation. Okay, meaning that there will be no duplicacy in the array itself. Okay, and that's the whole idea of using permutation. So we actually don't need to create this array more. You know, uh, we don't need actually create this array every time. Meaning we can just create the array called util, let's say for this point, which will be of size 51, since we need n is equal to 50 to fit in. And every time we traverse from this one, zeroth index, and we put the both arrays element into it. So once frequency will be increased, let's say these are 0, and the one frequency will be 1 now, everyone is 0. Okay, now we found 3 here, so 3's frequency will be 1. Then we found again 3 and 1, so the frequency are increased, and so on. At every index, we just traverse this array and put that index frequency into it. Okay, that numbers frequency into it, and then just count the how many are greater than 2. That's the core idea. Let's code it for it. So there will be a frequency which will be new int of size 51, since it's mentioned there are that most where it's 51, right? So, and our uh, answer array. Okay, let's get the right. These both are the permutation, so the size will be same. So and then will be a dot length, right? Now uh, we need, let's say, the array C of size n. Got it? And for every I 0 to I less than n, okay, C of I will be get common elements, will pass I, the first A. Uh, I don't know why it's lagging so much. Then I, okay, and now the core function, okay, public and we need see the frequency also here. So it will be like A, B, then our frequency, then our index. And I'm sorry I put here. Okay, it should not be here, right? Okay, let's remove this one. Okay, on the input side. And okay, now everything looks fine. So first, what we need frequency of A of index plus plus, means whatever the number at this particular index, we are just uh, increasing frequency of it. Okay, frequency of B. Okay, and once we increase the frequency of that number which were present in at this index in the both array, now we need to traverse, or in uh, you can say direct the frequency from the You can see if f is greater than 1, that means the present in the both, right? So c and t plus plus, and this is our c and t. Initially 0, now return c and t. Okay, and at the end return the index, c array. Okay, so that is what I'm thinking. And that part we discussed, for every I is equal to 0, there is 0. So no, at the index for the both array at I is equal to 0, if the both elements are same, the answer will be 1. Okay, so let's try to run first. Is there any compilation issue to check? Okay, no, it's running. Now let's submit. So it's accepted. Great. So probably when I was trying to explain, so that time, I just uh, did not read this properly. I'm sorry for that. Okay. Yeah, this was pretty simple, but first we took time to actually, you know, uh, get the question. Once we get the question, we, solved it properly. So you can see there are spelling mistakes. Just ignore for now, and we can optimize. Let's see, we can optimize, but no, we need to solve the gigs for gigs question also, right? So let's try to solve the gigs for gigs, and once we solve the both question, then we can think about the optimization. So it's, I don't know why, but for the first time it's lagging. It's, I don't know why it's so much lag. Okay, now let's see. We can start the timer. Uh, Product pair. What does this mean? We are given a target, determine whether there is a pair exists, and if exists, then return the target. What does this pair mean? Only two elements meaning pair, or there might be three. Okay, so let's see this. 10 into 40, it's 400. There are negative numbers also. Okay, so we have uh 10 and then 40. And then it's sort of false. We cannot achieve 30 from these elements. Okay, actually it's a product. There was similar question like sum, and this is the product one. Okay, so how you can do it? So since it's a product, the two negative numbers are also a good example to make this target, right? So uh, you know and what I am thinking is about the hash map. Okay, we can put all the elements into the hash map, and it's a brute force, I'm thinking. Okay, uh, the one thing also we can do in the n square. Okay, but the size is 10 to the power 5, so we cannot do it. Okay, which is put the first loop for the first pair in the first element of the pair, and then second loop for the second element of the pair. Okay, and that way you can do it. This is a brute force, but now since we need uh, the some sort of good example in a good algorithm which actually pass this one. So one is hash map. At this point, we can put the elements into the hash map and traverse a target divided by that number is present. Check that present in the hash map. For example, 10, 20, 9, 40, right? 10, 20, uh, 940, and the target is 400. So we know if there is pair A comma B, which actually gives target 400. Okay, it's what it does. A into B is 400, right? So if we put the bit elements into the hash map, let's say 10, 20, 9, 40, and we travel for the A1, okay, for this A, let's put this as a A, and we need to check the B is present in the array or not. So for that, you can simply do 400 divided by A, which is actually B, right? So we can check this B is present in the array or not. For example, let's say these are minus minus, okay? So the 400 divided by minus 10 will nothing but minus 40. So we need to check that minus 40 is present in the array. Okay, I think you are getting the question. But one thing we need to check that is that we can should we can either uh, the same element is taken twice. We have to check that it should not happen, right? So it might happen that there are two elements, okay, uh, on the different index, okay, and these are same. So we have to check that one also. Is there something that telling us? Okay, so it might happen that it's not mentioned here that every element is listed. Okay, so it might happen that we can uh, have duplicates. Okay, so we how we can avoid the duplicate stuff. Okay, so we can put the elements along with the list of index. Okay, and the index is the if the index is the current one, we not include it. Okay, meaning let's say for the 10 minus 10 minus 10, so it's 0 1 2, and we need to perform the target 100, right? So we can put the index like minus 10, which is present on the 0th, 1st, and 2nd index. And if we are at this one, considering this as A, okay, and our B will be like B is equal to 10, 100 by minus 10. So we need minus 10. So these are present on these indexes. So first will come 0. No, we are not going to include the 0th index since the this index we choose for the A, right? We need another index for the B. That is what I'm saying. Let's see the map of integers, list of integers. This will be uh, map new hash. Okay, and this will be our length of the array. Okay, good. For index I 0 plus plus I map dot put uh first get thing get or default AR I new array list, okay, which will be our list of indexes, okay, for this particular number. Okay, and we just indexes dot add I, and at first put array of I access. Okay. Now we have this map. Now that's A is equal to 0 to A. A is less than uh, N A plus plus, no, plus 2 plus plus A. And we need B, right? So B is equal to target by A, array of A. Okay. So instead of A, I can put it like I. It's just seems good for me. Okay. Now we need this one, and uh, this is our A, target by A, which need B. So if indexes dot contains B B not contains, then continue. That means we don't have a pair for this. Okay. Actually, we just need to, return true or false. So, uh, we can at the last return false. Okay. If it contains, that means we can check, is it not the same index for IDX indexes dot get B if IDX is not equal to I, then return true. That's the code. Let's compile. Target. Okay, the target is long. Possibly the Lucy, the since we are converting long to int, and that is why it's showing something. And the other is indexes variable not okay. Got it. Got it. So we need here long, right? And the another, this is not present. We have map. Okay. And every map has a list where we are traversing. So we have map. Everything looks good. Since we are checking the B is present or not. Okay. So it should be int. We can typecast here. Okay. After this, let's check. Pass. Let's submit. So it's failing somewhere. We are passing true, but actually it is not. Okay. So whatever the target, maybe something happened with the target. It might happen that target is not present. So let's convert it into the long, or you can check actually double. Okay. Let's convert this into double to check is there floating value or not, right? Oh, that we can check also via this. If target modulo A is not equal to 0, continue, meaning we cannot divide properly this target. Let's download this input, okay, and try to check that case. Okay, it's downloading. Let's wait. Finishing download. Okay, it's downloaded. Now let's open it and copy this and then paste here this array, and the target is probably 125 is the target. This is 125. Let's check the expected outcome first. It should be false, right? So let's check our output. So which is giving also false. Now let's submit. So it's passed the test cases. I think I am done with this thing. Okay. Uh, there is very long video. So we take 10 minutes to solve it. Okay. So thank you. Thank you for watching. If you really watched at this point. Okay. Uh, so yeah, bye bye.